Great. Alrighty, we're going to start working on the OpenStack request message flow. This gets quite intense and quite deep. I'll look forward to questions afterwards. So the problem with OpenStack is there's a lot of moving parts. All right. We'll talk about all the various parts, but basically all these parts connect via two different ways, either a REST API or a message queue. All right, a little overview before we start. What is REST? REST is really a way of two different services talking to each other, principally using HTTP style communications. Basically, if you actually looked at a REST request, it would look like a URL. It's very, very common in web interfaces. So the public APIs of OpenStack services. All right, great. So the public APIs of OpenStack use REST, and that's how clients, for example, connect. So when you talk about REST, you get into different types: get, post, put, delete. And so these are basically, if you notice, all look like URLs. So you need to be somewhat familiar with REST. The other way that things talk is basically by message queues. This is what's called pub and sub, or producer and messages. So literally, when you start looking at OpenStack, the internal components of a particular service will actually use a message queue to communicate. So as we walk through the message flows, take note whether it is actually using a message queue or it's using an HTTP request. Okay, when we look at the top level components, these are the slides that everybody sees. All right, and we usually say that each service is independent, but actually the services intercommunicate quite extensively when you start looking at applications. So they will use both the REST as well as the message queue APIs, and they definitely use each other. I think one of the things you will find surprising here, Keystone is a very important part, even though often when we're doing OpenStack presentations, we don't usually think much of Keystone, we kind of ignore it. So obviously we need to watch what's going on in order to figure out what's happening, and there's really the principal way of doing this is via logs, and there's a large number. Per host, there's several logs, and different logs also live on multiple hosts depending on how your OpenStack is set up. So to really follow a single request, you need to go across all of these logs, across all of the hosts. So it gets to be a rather interesting problem. Just to give you an idea of what the different log types are here. The principle is when you're trying to explore the message flows, either to measure performance or to find a fault, there's a lot of places to look. Now, obviously, people have solved this problem. And one of the ways that if you look at best practice that large clouds are using is they actually start setting up rsyslogd, and they use Logstash and Elasticsearch. This gives you a lot of things. First, it gives you the ability to search and find all the different parts of a single request. As you walk through the presentation here, you'll get an idea of that. And it also lets you do dashboards and KPIs on OpenStack as well, because when you're looking at OpenStack and message flows, typically you're either looking at a performance problem, something is happening too slow, something is timing out or dying, or you literally are hitting a bug. And so obviously to follow through, you need to look in a lot of places. So having the ability to search is very, very important. This was one of the things I found out as I was going through this, that it is a lot of work to follow through a request. And this is one way of making it simpler. This is one of the tools of making it simpler. Obviously, in open source, there's always a lot of different ways of doing this. I mean, you can SSH into each host and follow through and grep and do regular expressions, or you can have a nice GUI and coordinate it. When you look at the Facebooks and the Amazons of the world, seems to be using Logstash seems to be something that's very, very common. I saw this across several different implementations talking about it. So it's something to consider when you start looking at larger and larger POCs or production clouds. So the problem you get into is obviously when you do a message flow, you're trying to do an operation. So in this case, what we're looking at is actually creating an instance or a VM. Ideal case, we get that VM. The problem is, along the way, things can happen. So did it really work? I mean, you could literally get everything is okay, it worked, I have an instance, but the instance still not be running. So we need to dig in and figure out where it failed. We also need to look at response times and KPIs, because it may be that, hey, all of a sudden it's happening too slow and we're getting timeouts, which when you start looking at OpenStack, it's not uncommon to have issues with timeouts, especially as you try to do heavy workloads. And so understanding the message flows will help you both for understanding those issues of scaling, as well as looking at literal bugs and problems as well. So how do we track this? How do we follow through things that are so loosely connected? And in OpenStack, this is principally the ID or the UID of the instance. As you can see, you start getting an idea of there's 4 different places you would roughly see this ID on at least 2 different nodes. But this ID is the thing you want to look for that helps you identify things related to this flow. All right, so let's kind of give you a high level before we dig in to the details. Obviously, when we start things off, we're either going to use the CLI or we're going to use the dashboard to say, hey, let's provision a VM. This kind of starts life in Nova Compute. Glance gets involved for the image. Neutron gets involved for the networking. Cinder gets involved for the block storage. Keystone gets involved all over the place, as you will see. And then obviously we get into the message queues to handle internal communications as well between all of these components. So hold that in your head as we walk through it step by step. So here we go with the messaging flow. This is the base diagram that we're going to use all throughout of the moving pieces. Don't worry, it's pretty well on each slide. So we start off and we're coming literally from a dashboard of the CLI. If you're using a third-party management system, it would also use effectively the same API. And the first thing we do is actually authenticate with Keystone. Hey, are we who we say we are? All right, before you can start, you need to get a token here. So that's the first step. Now that token is carried throughout. So Keystone authenticates the credentials and generates this token and sends it back. All right, and that token is carried on and revalidated. This is part of the security architecture of OpenStack. All right. At this point, we literally take this instance request with that token and we go over and make a RESTful request and send it to the Nova API. So this effectively looks like a URL going into the REST API of Nova Compute to kick things off. All right. First thing Nova does is it reaches over and says, hey, is this a valid token with Keystone? All right, and this type of validation is continuing to prevent people from trying to play games. So we will ask and say, hey, is this a valid user? Is this token really a valid user? And does he really have permission to do what is going on here?
So hang on, can I ask a question about mine? This going to be like
so at this point, Keystone does the validation on the token, checks the permission, the roles, everything. This is very commonly where I've seen your first problem area. If you have permission issues, this is where you need to start looking right here. All right, after we've gotten that, Nova API is going to go over and start interacting with the Nova database. So we actually at this point, we actually create the initial entry in the database. So it's starting to begin to exist at this point. Now, note at this point, we're still talking on the controller node. All right, we really haven't went down to Nova Compute at this point. All right, now Nova API sends an RPC request. Now, when we say RPC request, we're actually talking about using the message queue to the Nova scheduler. So, which you would actually be able to see via RabbitMQ management interface or the command line interface as well. Now, of course, the scheduler does a lot of work, and we'll talk about that in just a second here. So Nova picks up this request from the queue, and it finds the host. Now, that sounds simple, and on a one host POC, that is simple, but the reality is this is a lot of work goes on. There's a lot of filtering and waiting going on. Because when you think about it, typically in OpenStack, you're dealing with a large number of hosts. Where should this go? And I've even had some customers say this is their proprietary intellectual property of how they select the host based on load and a large number of variables. So a lot of times the scheduling issues in Nova are where a lot of customizations are. Obviously, this also tends to be the issue of where a lot of problems can creep in with the Nova scheduling. In the end, we get back a host. So the Nova scheduler sends back the appropriate host ID, and then after doing all this filtering and waiting. So now we're ready to send the request over for launching the application on the appropriate host. All right, so there's a Nova compute service running on every host. So this is another RabbitMQ or message queue operation that talks to the host. Now, one thing to note is generally in OpenStack circles, the Nova compute host is considered the least secure environment because this is where actually user applications are running, user VMs. All right, and this is the first time really you kind of see a flow between the controller node running Nova Compute and the actual host node.
So we're not suggesting a third-party audit be needed.
So at that point, we go through and we talk to the Nova Conductor. Now, the Nova Conductor actually is at this point a proxy to increase security. Because literally since the less trusted nature of the Nova Compute host, you don't want to have a direct connection to the database. Now, do note that long-term that will change, and you will actually see the Conductor start doing more elaborate type operations. So the Conductor picks this up and literally figures out, okay, let me pull the database information back. And you could note that you could actually have multiple Nova Conductors. Now, one thing you have to be careful of, the Conductor typically is not installed on the Nova Compute host. So you literally can't scale it by doing it that. It's expected to be on a separate host. So we get the request. We interact with the database. And this was the kind of the note I was saying before, that as Nova Compute or Nova Conductor expands in the future, long-running tasks will actually get moved into Nova Conductor, and it'll be more than just a proxy. For now, it's effectively a proxy. So we get the instance information. Notice we're in step 17 already. We pick up the response. At this point, note that in order to have followed this, the logs are on two different hosts, the controller node that's running the Nova Compute service, the Nova API service, as well as on the compute host itself. All right. Now, at this point, we do a RESTful call going to Glance to get our image, and we get the image onto storage. All right, so note that we switch from doing an RPC call here or a message queue call back up to REST to reach over and talk to Glance. All right, again, Glance will validate back with Keystone. Hey, is this a valid token? Just to prevent denial of service.
It's unfortunate that we can't.
And then we get back the image metadata which if you look over here is kind of the ideal of what we would get back. Obviously, the image as well happened. So at that point, we go over to Neutron. At this point, we need to set up the network. All right, this is one of the key points. Without an IP address, we're not going anywhere. So we reach over and talk to Neutron, or this is now at this point, we're reverting back to also supporting Nova networking as well. We've again validate with Keystone. So you notice when you're looking at KPIs, the Keystone performance is going to really affect every time you spin up an instance quite significantly. So that's something to keep in mind when you're tuning. Neutron at this point gives us the network information back. At this point, we would have an IP address assigned as well. So we pass the auth token over to get a volume via sender. So at this point, we're using the sender API. Sender again validates that with Keystone. And then we get the block storage information. So we finally have a place to go to as far as block storage. Now, this is actually the payday here. Finally, we have everything we need to talk to the hypervisor driver and execute the request via LiveVirt to actually get the instance created. We have networking information, we have storage information, we know the instance we're running. Obviously, if you look at this, is a lot of things can go wrong in the KVM side when all of this is getting set up. So even though this is a single step, if you deep dive, you'll find lots of interesting details in KVM. So as you go through these steps, there's a nice mapping of what the state is we'll read in OpenStack. As you can see, if you go back through the slides, the state over time changes from scheduling, networking, block, spawning, and then none. So of course, the problem you have is you still haven't got a usable VM at this point, assuming everything went perfectly. So if everything went perfectly, the first thing that happens is Cloudinit. Some of you may not have looked at Cloudinit, but basically this is a somewhat cloud-independent way of getting some basic things initializing. Cloudinit, for example, gets the SSH keys, so there's no root password involved. It dynamically resizes the volume for the boot volume, so your image doesn't have to be the size of the whole disk. It can pass user data as well. In Horizon, you can specify user data. You can also pass that in the RESTful calls if you're doing this directly. You can run some additional scripts, install some additional commands and packages as well on first boot. So Cloudinit does a lot of things. So one of the things is you would have actually got a success back from create me an instance, and if Cloudinit has problems, you're still pretty well DOA. And in a OpenStack that's fully set up, this is one of the, and has been known to be working, Cloudinit becomes one of the problematic and interesting areas that causes issues. So that gives you the dime tour of how OpenStack does messaging. I'd be perfectly open to answer questions. Let me go back to the window for that. Okay. Any questions?
They love their meetings. Their favorite thing to do. Yep, I agree.
you have any target date?
Okay. Hmm. Yes. Okay.
When HP receives this order from that team, maybe they are receiving this order from that team, it takes 3 to 4 days to process in normal circumstances. And
Okay.
you can expect the order by Thursday or Friday.
Wow. That's for them. They're very enthusiastic. Oh, good. I know you're always very enthusiastic. Yes. You mentioned last night? Or is it tonight?
Hi, Glenn. There's a question from Richard.
Yep. Hey, Richard. Yes, with Logstash, Stash, you set up rsyslogd. There is a way of getting practically all the logs there as well. There's also some instrumentation you can do to actually also grab database information as well. Because obviously, in order to get a complete picture, you need the logs, and you also need some database information as well. So it's quite hefty. And in order to be able to get a real-time look at what's going on, you need the logs and you need the database transactions. But there are instrumentation in Logstash and Elasticsearch to be able to grab a large percentage of that, so you can actually get a picture. Yeah, the Cloudinit, actually, if you want to play with this, Tony, you can actually even play with Cloudinit outside of OpenStack. So you can actually sit down and actually, even in KVM, you can actually, the way you can play with it is one option of Cloudinit, it can look at an ISO image. And so when you fire up your VM, you can set the parameters, and that effectively then Cloudinit will go and use the parameters. So there's a few ways that Cloudinit works. Either it can look at an ISO that's attached to the image, or you can also do this via a standardized IP network as well. So it gives you a chance to play with it. Even some of the issues I know that's come up, for example, of setting IP address and setting other things, you can play games in Cloudinit. So Cloudinit really gives you a lot of ability to tweak and tune in an automated fashion details. And if you go and look at the Nova API, there's a way of user data is actually passed via Cloudinit. So you need to understand the Cloudinit portion of it. For example, one of the things I routinely do now is I use cloud images just running under normal KVM using Virtual Manager, and I'll write my own little ISO out there to pre-configure the SSH keys. You know, you don't need to be running in a cloud to use Cloudinit, and so it helps you a lot to understand it. But in OpenStack, Cloudinit is pretty well a foundation. You can there's quite a bit of info available on it. Other questions? Well, obviously, it gets real interesting when you're talking about a Windows VM in Cloudinit, because Cloudinit is actually designed for Linux. You'll have to dig deep to look in Windows to see how you're going to pass data to a Windows. But Windows doesn't have so much as a concept of dynamic configuration as Linux does. Linux is kind of like you go up and then to initialize it. There has been discussions of using heat and some other things to do it in Windows. But if you really want to look at Cloudinit in Windows, then we can have an offline discussion. You mean in Windows you could only sysprep? Yeah, sysprep is the way currently is the normal way in Windows. Windows is not very cloud friendly, so you can do sysprep. There's a few things you can do to automate Windows, but when Windows in the cloud is a lot of extra work. compared to Linux.
Mm-hmm. Okay. Okay.
Sure, Tony. Other people got questions? So I think, two things here that I found was to play with is look at Elasticsearch to see if it helps you and learn Cloudinit. In the end, Cloudinit is the one place you can instrument in an automated fashion VMs that are starting. It's not difficult. It's just takes a little getting used to use Cloudinit, but it does make things quite a bit faster.
Yeah.
And by the way, the file that Cloudinit reads is pretty well a standard text file, so it's easy to create it by hand.
I think so. Yeah.
Okay. Anybody else got questions?
Yeah.
I'm happy to share the deck. I also have a set of logs, as well as I'm happy to share if you don't happen to be doing OpenStack on a daily basis and would like to get a set of logs. But yeah, there's not only the OpenStack logs, but there's Open vSwitch logs and other components that you need to look at. But I do have a complete set of logs if the people want to go and sniff and see how fun or hard or whatever your viewpoint is of going through the logs. But I think from looking at it, if I was operating the OpenStack, I would put up Elasticsearch, just simply from the dashboards and the analysis that you can do. And Elasticsearch is really a big data application design just to understand these kind of things. Okay. Looks like everybody has asked the hard questions. Thank you all. Feel free to drop me an email. Happy to discuss any of this if you wish.